Okay, now we're going to be looking at the elimination method. In the elimination method, and the substitution method was always about isolating an x or a y. In the elimination method, we're going to be looking at columns. So we're going to look at the x column here, the y columns, or the constant columns. And the idea in the elimination is that you can add columns. So if we added our columns just the way they appear here, we'd have 7x. We'd have 0 y's because it's like a positive 2y and a negative 2y, so 0 y's, and that would equal 21. So we find that 7x's equal 21. Well, if 7x's equal 21, we could divide both sides by 7, and x would equal 3. Well, if x equals 3, all right, we're kind of halfway to solving our problem. So we know x equals 3. We can go back and say, well, if x equals 3, what could y equal? So we kind of do a substitution here. And we'd say, well, if x is 3, we really have 3 times 3 here because it was 3 times x. Plus some 2y equals 17. So that's 9 plus some 2y equals 17 if I subtracted 9 from both sides. Let's do that. 2y equals 8. All right, 17 minus 9 is 8. Therefore, y would have to equal 4. So the solution set for this problem is 3, 4. That's the number that solves both the first equation that we were given and the second equation that we were given. It's the x and the y's that work for both equations. Now let's look at what would happen if we had an equations like we have here, like a system of equations. And if I looked and I said, okay, if I want to add the x column, the y column, and the constant column, now it doesn't help me that much because nothing becomes a 0. So I'm not going to do that. I'm not going to add those because it doesn't become a 0. But what I can do is I can manipulate one of the equations so that it can become a 0. Manipulating an equation means that you multiply each and every term of the equation by the same value. In the second equation, it makes sense if I multiply each and every term here by a 3. Okay? So I'm going to multiply all of the terms by a 3. So taking the first one, I'm going to, it would be 3 times 2x, which would give me 6x. Minus 3 times y would give me minus 3y. 3 times 18 would be 30, what's 3 times 8? 40, 54. Okay, so now I'm going to just copy the top equation down. 4x plus 3y equals 16. Now hopefully you can see the genius in this, in that now when I add my columns, I'd get 10x here, I get a 0y here, and what am I going to get over here? I'm going to get 60. So I'm going to get that 10x equals 60. Well, if 10 times something equals 60, x must be a 6. All right. Oh, you know what? I just realized I made a mistake. Sorry, guys. It's a 70. Got to go back and make it right. Yep, because it would be 70 there, and it's 7. All right, so my x equals 7. Okay, now I know one of them, and once you know one of them, it actually goes pretty quick. I'm going to go back to my original equation here, and it really doesn't matter which. I'll go back to the first one, it doesn't matter. But now I know that 4x is really 4 times 7, because I know that my x is now a 7. Plus 3y equals 16. Well, 28 plus some 3y equals 16. Now I can subtract 28 from both sides, take away 28 from both sides. My 3y would equal a negative 12. So my y is going to equal a negative 4. So the set of numbers that worked here was 7, negative 4. Okay, so now I'm going to show you the same systems of equation, and I'm going to do it both ways. One way you could do substitution, one way you could do elimination, and you just kind of have to see what occurs to you first. So if I looked at this and I said, okay, I want to do substitution, I'd look at the first equation, and x plus 3y equals 13. And that means x alone would equal a negative 3y plus 13. So what I did there is I kind of said to myself, how can I take this 3y and bring it over to the other side? When you bring it over to the other side, it becomes negative. Okay? So I decided I'm just going to move it over, and that's what I did there. So, all right, 13. So then, if x is the same thing as negative 3y plus 13, then in the second equation, 5 times x would be 5 times negative 3y plus 13 plus 6y equals 29. Okay, distributive property now. 5 times negative 3y is negative 15y. 5 times 13 is 65, plus 6y equals 29. Combining like terms here, negative 15y and positive 6y would be negative 9y plus 65 equals 29. Now I'd have to subtract 65 from both sides. Subtract 65. Oh, my writing's bad. Sorry about that. Negative 9y equals negative 36. So negative 9y equals negative 36. And if I divide both sides by negative 9, y would equal 4. I then go back and I'd say to myself, well, and I'm running out of space here, if y equals 4, what does x equals? X equals 3 times 4, x plus 3 times 4, x plus 12 equals 13. X would have to be a 1. Okay? So now let's look at, okay, what if I looked at a different way to solve this? Now I'm going to say, what if I had the same problem and I wanted to do elimination? In the elimination method, I might look at the first one and I might multiply the first term by a negative 2. Each and every term by a negative 2. So negative 2 times the x would be negative 2x. Negative 2 times the 3y is negative 6y. Negative 2 times the 13 is negative 26. Now the beauty in that is when I copy down the second equation, you might be able to see real quick that when I add those two together, I'm going to have the y's drop out or be a 0. So this would be 3x, and then I have my zeros for my y equals 3. Therefore, I could figure out pretty quickly x equals 1. Well, now that I know what one of them is, you just use them and substitute it into either equation. It really doesn't matter which one equation. I almost always use the first one, but it doesn't matter. So we know x plus 3y, or 1 plus 3y, because now we know that x equals 1, equals 13. Subtract 1 from both sides, 3y would equal 12. Therefore, y would equal 4. In both examples, we found that x is 1 and y is 4. So you're going to get the same answer whether you use the substitution or the elimination method. It's just kind of what occurs to you first, what works. And you might be doing it different from the person next to you, and that's okay.